Welcome back to our lecture. Last time we had lecture, we were looking at the formation of nucleosides. Okay, I'll start from there. So I picked one pyrimidine and I picked cytosine. Okay, if you get cytosine, okay, if you get cytosine, that is your cytosine. Okay, that's our cytosine. Now, if I react cytosine with a ribose sugar, okay, that is our ribose sugar. Okay, that is our ribose sugar. Okay. So what I said was that what would happen is that this hydrogen would react with this hydroxide. Okay. When that happens, you're going to lose water, of course. What I've circled will come out as water. And then I'm going to I'll start with the sugar. Okay, that's my ribose sugar. Sugar. I have my CH2 hydroxide terminal there. And then my base is attached here. So for the sake of clarity, I'll use a different color. Okay, just for the sake of clarity. Okay, you have the oxo group there. A double bond there, you have a double bond, and you have a amino group there. Okay. So what I said is that what we have formed is a glycoside. Sugar react with a substance, they form a glycoside. So I said this is a glycoside. This is a glycoside. But I went further and said that the type of glycoside that is formed is an N-glycoside. Okay? The type of glycoside that is formed is an N-glycoside. What we are referring to is this one. This bond here is an N-glycoside. Okay, N-glycoside. But what we also see is that in which configuration is the sugar? The sugar is in the beta configuration. So this is a beta N-glycoside. N-beta glycoside, or rather beta N-glycoside. Remember, the beta is referring to the position of these with reference to the terminal. When it's pointing above, and this is pointing above, then that's beta. When this is pointing below, then that becomes alpha. Okay, right. Then I said that this glycoside that is formed is actually called a nucleoside. A nucleoside. What is a nucleoside? A nucleoside is a glycoside of nitrogenous bases. Okay. A nucleoside is a glycoside, an N-glycoside that is formed when a nitrogenous base reacts with a sugar. The particular sugar in this case is a ribose. Okay. Right. Now I've written it that way. You may actually decide to write it differently. You may decide to write it differently. Okay. I just want to make a comparison. I want to write it differently. So I want to write it this way. Okay, I basically want to distinguish it. Okay, so as usual, I use a different color. So, okay. Okay. Right. So you have an oxo group there. Okay, you have a double bond there, and you have a double bond there. Is it the same compound? No, it's not. Okay, this is facing this side, the other one is facing this side. Yes, this is a beta N glycoside. Okay, but there is a difference. Okay, let's look at this N glycoside, this bond we are calling N glycoside. Let's use it as a reference point. Okay, look at the terminal hydroxide and the molecule of the base. If you look at this as a sort of the reference point, you find that the terminal hydroxide is pointing to the left, the bulk of the molecule is pointing to the right. Okay, if I look at this line, the terminal of the sugar is pointing to the left, the bulk of this molecule is pointing to the right. Or if you want, you can use the oxo as a reference point. The oxo for pyrimidine is pointing to the right. If you look at this one, use this as a reference point. The terminal hydroxide is pointing to the left. The bulk of the molecule, or the oxo group, is also pointing to the left. They are all pointing to the same side. Here, they are pointing to different sides. So if they are pointing to different sides, this configuration is called the anti-configuration. This is called the syn configuration. Okay? So this is the anti-configuration. This is a syn configuration. What's the reference point? The N-glycoside. Okay? And then you use the terminal hydroxide and the oxo group for the purines, for the pyrimidines. So if they are pointing in the same direction, then it's a syn. If they are pointing in the opposite direction, then it is anti-configuration. Now the question that will arise is that which one is common? Which one predominates? Okay. Right. The one that predominates is the anti-configuration. So in most cases you find the anti-configuration because this is more stable than this one. Here, because of steric hindrance, or because of the steric effect, this will be a bit unstable. Therefore, the anti will be the most predominant one. There will be a few exceptions, but the most predominant one is the anti-configuration. Okay? Right, so keep that in mind. Now let's look at the names. How do you name the nucleoside that has been formed? Remember, the base here is cytosine. The sugar is a ribose sugar. Okay. Right. I'll also use the other ones, say uracil, thiamine. So if I have cytosine, the name of a nucleoside will be called the cyto. Okay. So you remove the S-I-N and replace it with the D-I-N. Sorry, you replace it, you remove the O-S-I-N, replace it with I-D-I-N-E. Cytidine. Cytidine. Okay. Right. For thiamine, okay, you again replace the I-N-E, okay, I-N-E with the I-D-I-N-E, thiamidine. Thiamidine. For uracil, it will be uridine. For uracil, you replace ACl with the E, cytidine, uridine, and thymidine. These are nucleosides. Okay, these are bases. Okay, this is the sugar, and this is the nucleoside. Nucleoside. Now let's look at if we consider the others. Okay, let's look at the nucleoside of purines. We have looked at nucleosides of pyrimidines. Let's look at nucleosides of purines. Okay. So I'll pick one purine. That is a purine. Okay. This is a purine called adenine. Okay. I react this purine with the ribose. Is the ribose. Okay, like we said. Okay, I need to be careful that it is balanced. Remember, we said there is a hydrogen here, right? Okay, so what will happen is that this hydrogen reacts with this hydroxide in that manner. Okay, and in the process, water is lost. Process, water is lost. Okay, and what product is formed? So I'm writing the product here. Okay, I have this nitrogen here. I will write it in a different color for the sake of clarity. Okay. Okay. Right. So we are saying that what would you call this, syn or anti? Remember, we're using this as a reference point. The bulk of the molecule is on your right. The terminal here is on your left, so they are opposite sides. So this is an anti-configuration. This is the anti-configuration. Okay. Okay. Remember, this is adenine. Adenine. Okay. The product will be adenosine. Adenosine. Okay. Adenosine. Okay, so my plus adenosine. Adenosine. Okay. So if you had guanine, then it will be guanosine. Okay. So these are nucleosides of purines. If you are very observant, nucleoside of purines are ending in S-I-N. Nucleosides of pyrimidines are ending in din. So you have to take note. Don't make that mistake as it were. Right. Okay. Now, there are certain chemicals that have similar structures to nucleosides. Okay? There are certain structures, or rather there are certain compounds that have a structure similar to nucleosides. Those are called nucleoside analogues. Okay? Nucleoside analog. Nucleoside analog. Okay, so let's look at a few nucleoside analogues. What are nucleoside analogues to start with? Okay, so if I may define it, these are compounds that have similar chemical structure to, so these have similar chemical structure to nucleosides. Okay, a nucleoside analog is just a compound that has a similar chemical structure to a nucleoside. We learn about nucleoside analogues. Nucleoside analogues are used in the treatment of HIV, they are used in the treatment of cancer, they are used in the treatment of epizoster, they are used in the treatment of hepatitis. So a lot of drugs have been manufactured, okay, basing the synthesis on the structure of nucleoside. We mimic the structure of nucleosides, and therefore the nucleoside analogues will mimic the chemical reactions of nucleosides. Okay, so nucleoside analogues are used in the treatment of HIV, okay, in the treatment of a lot of viral diseases such as herpes, okay, epizoster, as you all know it, in hepatitis, and many other. They are just nucleoside analogues. Even cancer, I can't forget about cancer. Okay, some drugs that we use for treatment of cancer, some drugs that we use for treatment of hepatitis, that is the inflammation of the liver, epizoster, as it is called in the local language, HIV, these can be treated by nucleoside analogues. So let's look at a few examples of nucleoside analogues. Okay. I can start with thiamine. Okay, so I'll write thiamine first. This is your thiamine. This is it. I'm writing a nucleoside. Okay, this is thiamine. We have looked at it already. Okay, this is thiamine. Okay, now when thiamine is attached to a sugar, nucleoside. What is its analog? What is the analog of thymidine? Okay. Right. For a start, let me use different sugar. Instead of using ribose, let me use a deoxyribose sugar. So therefore, this will be deoxythymidine. Deoxythymidine, because the sugar is deoxyribose. What is the analog? Okay, what is the analog of this? Okay, so what was done was just to change the structure so that it resembles to a greater extent. And if it resembles to a greater extent, it means that its action will be very similar in the body. So this is it at carbon number 1 prime, carbon number 2 prime, carbon number 3 prime, carbon number 4 prime, carbon number 5 prime. So what was done to this structure, of course the rest are the same, CH2 hydroxide. Now what was done here is to remove the hydroxide and replace it with the azido group. This is the azido group. Okay, this is the azido group. I'll not put the hydrogen, but know that it is there. Okay, this is the azido group. So an azido group was put on position number 3 of deoxythymidine. So what can we say is the name of this one? So we can say we have put at position number 3, we have put the azido group. Okay? But for us to put the azido group, what did we remove here? What did we remove here? We removed we sort of removed the oxygen. So we would say 2 prime, but remember also, if we are thinking of the ribose sugar, we are saying at 2 prime the oxygen is removed. Also at 3 prime the oxygen has been removed. So we would say di-deoxy. Okay, deoxy means the removal of oxygen, but 2 of them, 2 oxygen has been removed from number 2 and from number 3. So we have 3 prime azido, because we have placed the azido group at 3 prime. Then at 2 prime, we have removed the oxygen from ribose. At 3 prime also, we removed the oxygen in order to put the azido group. Okay, deoxythymidine. Deoxythymidine. Okay. This is a nucleoside analog. It is commonly known as zidovudine. Others call it litrovia. Others still call it by abbreviation AZT. A for azido, okay? AZ for azido, T for thymidine. Okay, it's a famous drug that is still in use in the treatment of HIV. Okay? Alright, I'll give 2 more examples. Okay? Right. Keep in mind there is a CH3 there. Keep that in mind. I missed out the CH3. There is CH3 here. So there is a CH3 there. So keep that in mind. Now, if the same one, okay, and maybe let me deal with the thymidine itself. Let's say the analog of thymidine, another analog. What I can do is to remove the hydroxide, Okay? After I have removed, I leave the hydrogen. The resultant hydrogen, I also remove it. If I remove the hydrogen, then I'm going to create a double bond here. So what I have done is that at position number 2 prime, and at position number 3 prime, I have removed the hydrogen. So I can say dihydro. Remember, dihydro is the removal of hydrogen. So two hydrogens have been removed here. Okay? But initially, at the same position number 2 and position number 3, there was the oxygen, which I removed. So I would say dideoxy. There is oxygen, which I remove to start with. The resultant hydrogens that remain also I remove. So hence the name 2 prime 3 prime didehydro, 2 prime 3 prime dideoxy. This is thymidine. Okay, this is another nucleoside analog. Okay, it is commonly known as the stavudine. Okay, stavudine. Okay, stavudine. Okay, which its use is slowly. In fact, most regimens they tend to remove stavudine because of its toxicity. Okay. Now, I'm giving thymidine. Let me maybe pick another type of the nucleoside. Let me pick cytosine. Okay, let me pick cytosine. This is my cytosine. Okay, so this will be cytidine. This will be cytidine. Okay. Right. So what I can do to the cytidine is actually I can choose to remove. Remember, oxygen is in group. In which group is in the same group as sulfur, not so? Yes. So I can choose to remove the oxygen and put a sulfur here. Okay. And then remove this oxygen so that I only remain with this oxygen here. Okay. So what have I done? Okay. What have I done? So basically what I've done is that, so this oxygen is there, but instead what I do is that I put the sulfur here. Okay. So I can see at 3 position prime, I have put a sulfur,